Hello, my name is Jonathan Thomas. This is project 3 for Professor Ozbay's class. My teammate already did the 20 hertz and 40 hertz video, and I'll be doing the 60 hertz video. So let's get into it. So first, we're going to double click Fluid Flow Fluent, and then we're going to right click Geometry, make sure it is on 2D, not 3D. And then after that, we're going to right click again, click Design Model. We're going to let that load up. Okay, once it is loaded up, you click Z, click Select Plane. And as you can see, the plane here. So what we do next is we change the units to the inches. Okay, and now what we're going to do next is sketch, and then click line. Just make three lines sketching each other. Okay, medium-sized lines, because we will change the dimensions right now. The dimensions go to general and just one, two, three. Now we will change those to 24, 12, and 42. So right here, 24, 12, and 42. Okay, and now we're gonna zoom out and move it to the middle. Okay, so 24, 12, and 42 inches. Now we're gonna do is make more lines in between to complete our shape. So one right here, one right here, one right here, and then one right here. Now, one thing is we're not going to mention them again, but we are not going to dimension the fourth line because we're going to now go to constraints, midpoint, and connect the line to the edge of each point. So right here, right here, this one to the edge. And now you'll change the measurements to 22, 6, and 6. And we're going to move it over a little bit. We're going to take the line and connect the other lines. Boom, and boom. Okay, now what we're going to do is dimension, angle, 7, this one's 3. And as you can see there, that is perfect for the angle. And then now we're going to do is draw again, hit line, like two small horizontal lines towards the left for our inlet. And we're going to make sure we're going to dimension them. So dimension them to 15 inches each. So 15, that 15. And what we're going to do here is just connect them by drawing another line. Okay, perfect. And now what we're going to do here is just clear up all the stuff that does not need to be here. So we're going to click select, control, and click out all the middle lines that are there. And then right click and then delete. So now that looks good. So what we're going to do is now go to concept, search and sketches, click on the sketch one, apply, and generates. And there we have our surface. So now what you're going to do is you're going to minimize this and then make sure to update again just to make sure once it is. And then you're going to double click mesh. And you can exit out of Fluid Flow. right here. Okay, so now we're going to make sure wall. What we're doing right here is making sure we're naming all the sides of the shape. So inlet and outlet. Perfect. And now after that, we're going to make sure. Yeah, so they are all there. I'm going to click right click mesh, insert method, and we're going to click this, if we apply, then we're going to make this triangles. And I'm going to click generate. So when you click mesh again, and we're going to click the element size to 0.01 and then generate again. And now it should look like this, which is perfect. That is what you want to see. And now you should be good for the mesh. So you're going to let that update. And then you're going to click setup. You're going to make the solar processes 2 and double precision. You click start. You can exit out of this mesh because we have updated it. And wait for the setup to load. Okay. As you can see here, it is perfectly right what we need it to. So what we're going to do is we're going to go to models, click energy and click it on. Um, and then we need to change this to a laminar flow. So we need to make this laminar and we click OK. So we're done for the model part of that. Next is boundary conditions. And then we can double click boundary conditions. And the only thing we're changing is the inlet for the velocity. And so right here, for our project, we were given the equation 0.2489 F minus 0.1378 equals velocity. So we're going to plug in 60 here, and when we plug in 60, we get a velocity of 14.5622. And since we're using AV equals AV, we now do 14.5622 over 22 and solve for the inlet velocity, which we end up getting 3.9715 for the inlet velocity, which is only for the 60 hertz. And my partner has done the 40 and 20 hertz with the same equation and double check to make sure the velocity is like that. That is the only thing that should be changed. So beyond that, you should have nothing else to change for boundary conditions. So apply and close. And then you just want to check on the reference values pretty much and make sure, let's see if I can run this. What just happened? Yeah, not bad. Reference value. Move this over. Go to the inlet. After you click inlet, you want to verify to make sure the velocity and everything else, nothing has been changed. And then um, we should be now good enough to go to initialization. Initialize, good. And then go to run calculation, number iterations to 150. Then calculate. Perfect. Now we're going to go to our one or no, our graphics and we're going to go contours. So for this project, we have to do our velocity contours. We're going to click velocity, velocity magnitude, and then save and display. And as you can see here, this is a really good flow going right through the middle, and there's no leakage of any sort, which is really nice. Next, we have to show, as you can see in here, our values as well. And then now we do pressure contours, and first we're going to do static pressure, save and display. And this looks really nice compared to the same 40 and 20 hertz, very similar. And now go to dynamic pressure as well, save and display. Very nice again, and you can see all the highest amount of pressure is right here. And then finally, the total pressure, no sort of leakage, and it looks beautiful. Now, perfect. And now we should go to the XY plots here. And we are now going to make it X. You have to now get the data for the center line. So we click new surface, line and rake, and then center line. And then our value should be 2.3622 used by my partner here and then close. So now when we do velocity, magnitude, or the center line, say plot, we should get this pretty much, which matches up. And then now for the dynamic, or for when now we change it to pressure, you get static pressure, say plot. That is for the static pressure right here on the right. And then right here is the dynamic pressure, which is right here. And then finally, the total pressure, which should have a little bit of, you know, this. And now let me pull up the Excel sheet. So we wrote these values to file and we were able to plot the velocity for all three. Same thing with the static pressure for all three, 20, 40, 60. Dynamic pressure plot right here for all three. And find the total pressure plot for all three. And we made sure by doing that, we put all the x coordinate values with the velocities at certain x coordinate values for each one of this velocity, static pressure, dynamic pressure, and total pressure. Thank you very much for watching.